Hello, everyone. Thank you for making it. I'm Kishore Konduri. I'm part of Core Services Engineering and Operations organization. I'm a senior software engineer in compliance data analytics and services team. My expertise is in building line of business applications. Today, I'm going to walk you through how we are using Azure Event Grid to integrate PaaS, serverless, and intranet applications. So by end of this session, you'll be able to understand how Microsoft Business Operations is processing the price change request in a compliant way by using Azure Event Grid. You will also be able to learn. You will also be able to apply this learning to your own scenarios, like how do you achieve real-time compliance monitoring, and also you'll be able to understand how do I process changes across multiple systems. How do I notify start of a user action or end of a user action to other systems, and then make sure that systems are integrated seamlessly. So let me get started with what we do in Microsoft Business Operations. So we launch many products. We receive millions of price change requests from business groups to support a major holiday event like Black Friday. We want to ensure all the internal systems are accurately reflecting the price change so that when consumers walk into Best Buy stores or Microsoft stores, you've got the best deals and systems are fully prepared to process your transaction itself. So we have got multiple teams within MBO. In this scenario, I'll walk you through how these three teams are actually working together and how Event Grid is actually solving their problems as such. So we have got a pricing architect team. So what they do is they receive a lot of requests from business groups, and then they review the requests. They'll ensure that we have got the needed details. Once a request is completely reviewed, they'll approve it, and then they'll pass on the request to portfolio planning team. Portfolio planning team tries to understand all the dependencies that are actually supposed to be put in place so that all the systems are fully processed, and then all systems can actually reflect their accurate price points. Compliance team, throughout the process, they should be able to understand, hey, what was the request that was actually received, who processed it, what all systems got updated, when did they actually update. So a couple of goals are there for our particular scenario. So we want to ensure all the processes that we are actually supporting are resilient, and also there is a near real-time visibility for compliant execution. So to achieve these goals, what we got started on is a journey of implementing reactive programming itself. How many of you are actually aware of reactive programming? Okay. So reactive programming is a paradigm concerned with propagation of change. So you may find a lot of reactive program-related stuff on the UI side, like all the reactive JSX files, anything that you would actually do on the client side. So this is a concept of how do you actually implement reactive programming for systems integration itself. So in this scenario, anytime we have got a status change, these are called events. So events are basically, they trigger all the business rule validations and calculations in our scenario. Some of the sample event types that we have been discussing so far is, hey, pricing request complete by pricing architect team and portfolio planning team complete the review of plan and execute or process changes in affected systems itself. Couple of benefits of reactive programming are scalability and extensibility. There is a reactive manifesto readily available. If you're not aware of it, I recommend having a read at Reactive Manifesto. It actually explains a lot of benefits that you actually get when you use reactive programming for systems integration itself. So to implement reactive programming, there is an offering from Azure. This is called Azure Event Grid. So a couple of benefits from Azure Event Grid is it's serverless. It's a push-based delivery. Most of you may be already aware of Event Hubs, right? So Event Hubs is basically a fan-in scenario, whereas Event Grid is a fan-out. Basically, it's a push-based delivery. You don't really have to keep on listening and constantly poll for a specific thing to arrive. So Event Grid will deliver to your subscriber itself. There is a native integration with Azure resources like Azure Functions and Logic Apps. So this is something that we were actually looking for, because when we got started on our journey, we've got multiple internal systems that we want to completely make it to cloud-native computation. When you want to go for cloud-native, and there is a Event Grid kind of a thing that's readily available, and it can directly have native integration, especially when you're using Azure Functions. The triggers that you get is an Event Grid trigger. So that helps you optimize many of the processing that you would actually put in place for this kind of integration as such. So Azure Event Grid also supports resiliency, and it also has support for low latency. And it actually designed for massive scales, but it can also be used for your line of business application integration as well. The limitation for Azure Event Grid is like they claim they can process up to 10 million requests per second. So not every line of business application maybe even having that kind of a scale. Even if you don't have a scale, in our scenario, we are processing millions of changes, but not 10 million per second yet. But we still felt like, okay, this is something that could actually work out for us. In long term, this is something that is more maintainable for us. So throughout the next couple of slides, what I'll be showing you is a couple of systems. I just want to give you a quick primer on, hey, which team is using which system so that you can easily understand this part. So pricing architect team is on PaaS right now, and portfolio planning team is using a pricing execution system. It's an intranet application, and compliance team has been using compliance system, which is a serverless. So to simplify the scenario, I've got started with only these three systems. We have got an ecosystem of tools. Obviously, from here on, there are more processing that are actually happening. So I just want to limit the conversation to these three systems so that I can effectively explain the concept of integration itself. So before I get started on, hey, how do I actually integrate with this PaaS serverless and intranet applications? I want to get started on what are some of the design considerations we need to put in place when you have something like an event grid. So how many of you are already aware of pub/sub models? So you already implemented a couple of pub/sub models, right? So you may also have questions on, okay, I've seen so many pub/sub models like Kafka, you have seen Redis Cache, you have seen Azure Service Bus, you have seen Event Hubs. Every pub/sub solution out there solves a unique purpose, and similar things apply actually to event grids as well. So the biggest benefit that we were looking for is native integration and also the fan-out scenarios itself. When you use event grid or any eventing mechanism, you need to ensure that your processes are ready to actually take in multiple events as well. So event grid ensures at least one-time delivery. What it means is event, it's not only delivered once, it could be delivered more than once. So your event handlers will have to be idempotent. They have to be designed in such a way that even if your event handler is actually executed multiple times, it results in exact same outcome. Order of events is not guaranteed. So what it means is I've got multiple publishers of these events, and I'm expecting a business rules to be triggered only when I receive X number of events as such. If at all I have got that kind of a scenario, you will not be able to directly use event grid. You may need to use internal queues or have some weight logic on your handlers itself so that you can properly process those kind of transactions as such. Event processing should be quick. So by default, the nature of events are lightweight messages that are supposed to be communicated across multiple microservices. Event processing, it's designed for highly scalable scenarios. So you want to make sure that everything is processed within very less number of seconds or even milliseconds in most of the scenarios. The reason I'm actually calling this out is if you have long-running queues that needs to be triggered based on a particular event, even in that scenario, you may want to use some sort of like event queues, the message bus queues or storage queues, depending on your specific scenario. You can use internal queues so that when an event actually comes in, you put it into the queue, and your long-running process can actually read from queue and then process it further. Enable filtering based on event types. So whenever events are actually coming in, filtering is something that's available at every subscriber level. So you want to ensure that you don't keep listening to every single event that's coming out there. You are interested in only X number of events. Your event handler will have to be triggered only for those events itself. You can easily configure all of that from Azure portal itself. And last one is pretty much a standard thing that you would want to do as part of your application design itself. You want to enable instrumentation at every step so that it actually eases troubleshooting. I'll go a little bit further into most of the design considerations when I discuss more on how do you do PaaS, serverless, and internet applications as such. So how do I do with PaaS or serverless? So the reason I actually club PaaS or serverless is it's pretty straightforward in PaaS or serverless scenario. Since I already said serverless has got native integration with Azure Event Grid, you can even have an Azure function and then register your Azure function as a subscriber. Publishing is also very straightforward. You need shared access token keys that you can easily generate from Azure portal as part of registration itself, and use that shared access key to publish all the events to Azure Event Grid itself. There is something that I personally found it very interesting with Azure Event Grid, endpoint validation. So endpoint validation is actually not needed when you have Azure Event Grid trigger itself. It's natively built, so you don't really have to write any special code for it. But if you want to do something like a PaaS implementation or a container with public cloud endpoints implementation, you definitely want to make sure that endpoint validation, custom code is actually written on your event handler itself. So when an event is actually coming in from Azure Event Grid, your subscriber will have to ensure that, hey, yep, I read this particular event. If the event type is a validation event, execute this particular code and make sure that I send back whatever head auth code is actually getting generated from Event Grid. So that way validation is successful, and Event Grid actually knows that, yep, this is something that's a registered subscriber, it's a valid client, I can continue publishing more events to this particular Event Grid itself, to the subscriber itself. And your Event Grid is directly invoked via Event Grid trigger. So this is a native function trigger readily available in your Azure functions itself. Similar things apply for PaaS. So publishing is using topic keys, and registering your PaaS endpoint is via webhook. So I'm sure everyone is aware of webhooks, right? So you just have to pass in the webhook, and then you can register endpoints in the portal itself. And as I discussed, endpoint validation will have to be a custom code, and it's invoked via webhook itself. So let me get started with how we do for intranet applications. So intranet application publishing is exactly same as PaaS or serverless. You publish via topic keys. Your registration will have to be using something like a hybrid connection over a relay service. So if you are connecting to on-prem, relay service is a way to connect to all the on-prem resources. So your relay service or hybrid connection will be registered as a subscriber to Azure Event Grid itself. So from there on, Azure Event Grid will be able to put in an event, and that event will be processed by your listener. So I'll go a little bit more detailed on how this thing actually works itself. So as discussed, endpoint validation is also needed, just like endpoint validation is not needed for internet applications, similar to Azure functions. Primary reason is you're registering via hybrid connection itself. So let me get you started with how we actually designed a couple of events to percolate through all the systems itself. So I said that I have got a product planning system, which is a PaaS system. I have got a intranet application, which is a pricing execution system. And I've got a compliance system, which is pretty much serverless. So the scenario that I have been discussing so far is, hey, I've got a pricing architect team who is actually creating a request and then approving that particular request itself. When the request is actually approved by the pricing architect team, in this case via PaaS application, event 1 is what I'm depicting here in the picture. So that particular event 1 will be published to Event Grid itself. And from Event Grid, I have registered my publishers here. The first registry is the compliance system. Second registration or second subscription essentially is my intranet application. So event 1 is published from product planning system. It goes to Event Grid. And the same event 1 goes to hybrid connection. From there on, I have got a relay listener. So relay listener will constantly poll for what exactly is going on, what is a new event that is being received. And once I get the event, the same event will be published to event store. So this is I'm just tying this back to one of the points I mentioned in my design considerations. I was saying that you have to enable instrumentation. You have to ensure that every single thing that's actually being published or being retrieved is available as part of some data store. And we are calling that data store as event stores. Event store concept has been out there for quite some time, and it actually is a very, very deep topic on how you can actually do replay events as well. I'm not discussing about the replay of events. So this is only for troubleshooting purposes for now. So once I receive the event and persist to event store, I can trigger my workflows. I can trigger my on-prem related services using a web API call. Once the workflows actually complete their execution, they can publish an event back saying that, yep, the pricing request was whatever I actually received. It's accurate. I'm able to publish all the changes to my appropriate systems. From there on, I'm publishing the request back via publisher. And publisher does exact same thing similar to what my listener does. It will also persist the event to event store, and it will completely push the event 2 to Event Grid. And from there on, the product planning system and compliance system, both of them will receive the event 2. I'm not saying this is the only way to integrate it. For my specific scenario, to suit my infrastructure needs, we went with this simple design. So one of the reasons we said we are actually going with this particular scenario is we said here resilient process is one of the goals that we have. So how are we achieving resiliency using this particular integration itself? So one thing that we have done for on-premise itself is for on-premise we have got hybrid connection. I can have multiple listeners listening to exact same hybrid connection. So that is one way to ensure that systems are up and running all the time. Most of the developers may already know about this kind of a technique as such, right? And Event Grid also supports event retries. So let's say event handler received this particular event, and that particular and your event handler is not able to successfully process it, or it's not able to respond back within 30 seconds. What Event Grid does is it tries to redeliver that particular message itself, so that the event handlers can effectively process that going forward. So the retry mechanism that's supported is exponential backoff. You can still configure this in your Azure portal itself. So the default timeout for all of these events to be available in your Event Grid is 24 hours. Within 24 hours, by default, you can configure up to 30 delivery retries. And from a timing standpoint, it will follow exponential backoff. Event Grid is also intelligent to actually figure out, hey, is your service healthily or actively listening to the events all the time or not? If at all, your event handler is busy, or it's basically not responding because of some other exception, or it is constantly throwing some exceptions, then Event Grid, what it actually tries to do is it tries to optimize the number of deliveries as well, so that your service will not lose any data, and it also gives enough time for services to completely heal as such. So you may have question on, hey, what happens after 24 hours? So like Service Bus and other messaging platforms, Event Grid also supports dead letter queue. By default, this is not enabled, so you need to go to Azure portal and then enable dead letter queues, so that you can actually get the message, and then after 24 hours, if something goes wrong, it's persisted into your dead letter queue, and then you can process from there on. And these dead letter queues are per subscriber as such. So pretty much, that's how we achieved resiliency, scalability, and low latency features of Azure Event Grid to actually execute on simple price changes in a compliant way. I'll be available in IT Showcase booth 27 if you have any specific questions, if you want to know more details on how we implemented, what exactly actually happened, and if you need more metrics, I can help you with that. Thanks everyone.